Really excited to be here with you. We're the city. My name is Merve Hickok. I am the founder of AIethicist.org and Lighthouse Career Consulting. When I saw the post from We Are the City on Paying Forward series, I literally jumped at the opportunity. Because in a previous life, about a decade ago, I was the first college diversity recruitment manager for Bank of America across EMEA. I was also in charge of the recruitment technologies for the college remit across the bank. So in its early days, almost a decade ago, I was involved with WATC's networking events. So being here, able to do this today is very close and dear to my heart. So thanks for joining and thanks for listening. What I'm going to do now is kind of do a very, very, very high level of some of the bias and ethics issues that are in discussion, that are in the debates for AI and currently, and then kind of do a focused discussion on what are the issues in some of the recruitment areas or recruitment steps. And at the end, if you have any questions, we'll be going through those questions. But let me start and let me take you through the presentation. So when we talk about ethics, we're really talking about, especially during these days, during the pandemic and all the lockdowns, etc. We're talking about the times testing our sense of ethics, morality, humanity, and our respect for each other. And we're making more conscious decisions or more conscious thinking about our actions, our decisions, and thinking of the implications of those. So this whole pandemic, one of the issues or one of the results of it for me has been seeing more people going into these debates. But when we're talking about ethics, we're talking about the question or the process of questioning, discovering, and defending our values, principles, and purpose. How we behave towards others, how we treat others fairly. Ethics is not law, it's not about compliance, they're not enforced upon us by force. If you're in a company, you might be doing all the right things for compliance or by legislation, but if it's not in your culture or if it's not in your values, you might still be doing unethical decisions and unethical actions. Ethics is really our rules that we follow voluntarily, how we associate right and wrong, how we create beneficial and just results about respecting the dignity of others. I used to have this big sign in my office when I was in office in a corporate world saying, common sense is not common. In that way, in a similar way, ethics is also, you have to make an intentional decision or intentional effort to have common sense. And ethics, in the same sense, cannot be taken for granted. You really need to be proactive. You need to be very intentional about what you're doing and your decision-making process, as well as your actions. When we talk about data ethics side of that, though, I really like this classification by Floridi and Tadeo on how they define data ethics, which is a branch of ethics that studies, applied ethics that studies and evaluates moral problems related to ethics of data, ethics of algorithms, and ethics of practices. And what that means is, what are the challenges and problems that might be posed by collection and analysis of large data sets, big data, and the issues ranging from that. And then moving on to addressing the issues posed by the complexity and autonomy of algorithms and the systems that are using these algorithms. And then moving on to ethics of practices, addressing the responsibility and liability and accountability questions around the practices that you use algorithms or automated decision-making systems. Now, when we talk about ethics, obviously this is not a new question, not a new topic. It has been around for thousands of years. AI ethics, although AI itself is relatively new, it's not the questions themselves are not new. I'm not going to go into the different kinds for the benefit of this call or this webinar, different aspects of different perspectives on ethics, like utilitarianism, virtue ethics, Ubuntu or Confucianism, or what have you. What I am going to focus on a bit more for the data ethics and ethics in AI is more relevant to the social justice side of things, and data ethics of rights, how we ensure a person's rights that then impacts the social justice and society at large, and data ethics of power, what happens when we are using data and algorithms as a means of impacting the power balances or skipping that balance if there was obviously any balance to start with. If you're familiar to some of the ethical AI or responsible AI principles that have come out over the last few years, which there are now more than 70 that are published, publicly published by different organizations, companies, institutes. All of them are looking at different angles of ethical AI. However, there are some recurring themes that are similar across all of them, which I kind of summarized here. So when we're talking about ethical AI or responsible AI, the discussions are really around the fairness of algorithms, justice issues, and issues that are concerning bias that might be embedded in those algorithms. We're talking about beneficence, so AI for good, and also AI and prevention of harm, the use of AI or application of AI and prevention of harm with that. We're talking about user data rights, respect for human autonomy and human rights, which includes issues around privacy and ensuring that humans are autonomous in making their own decisions. We're talking about explainability, how an algorithm or a system makes its decisions, accountability and liability issues around that, and then how that impacts down the stream the trust of individuals and society in these products, and value alignment of what is it that we use AI for, how we align values of the systems and their applications to our values of the society. This group, I'm pretty sure, is pretty familiar with issues of bias and definitions of bias, but just at very high level, when we say bias, we're really looking at tendency, inclination, and prejudice towards or against something or someone. It's only human to have these biases. We all have unconscious biases, if it's unconscious, that are based on stereotypes rather than actual knowledge or individual circumstances. Usually the biases come in handy for all of us in doing cognitive shortcuts to make a decision in a quick manner. But what that might mean is that those cognitive shortcuts can result in prejudgments that might lead to wrong decisions or discriminatory practices. In terms of how this relates to AI is, again, I like the definition from Alan Turing Institute here, because AI and algorithms gain their insights from existing structures and dynamics of the society they analyze, meaning all the data that an algorithm uses is historical data and has existing structures, dynamics of data within that, and that there might be biases embedded within that. AI can reproduce, reinforce, and amplify the patterns of marginalization, inequality, and discrimination that exist in these societies, which can then potentially replicate the designers' and developers' preconceptions and biases, and then is usually insufficiently representative of the populations from which they are drawing inferences. What that really means is, one, your output is as good as your input. So your output with algorithms is as good as the data that you put into it. And you have to be really, really careful about the context and historical aspects of that data and the data collection. But also, there are a lot of points where bias, and we're going to go into that in a moment, where bias can leak into the systems because of the designers' preconceptions and biases, whether conscious or unconscious. One thing important here is you might have gone through some of the unconscious bias training or have read about it. With the best of our intentions, we might not be aware of it. We all have bias. What is important, needs to be underlined is we actually, just like ethics, we have to make intentional, proactive action and take steps towards identifying our unconscious bias or others. So we can improve and mitigate the impact of those resulting from those unconscious bias. What the definition or kind of the summary that I just went through also means that it is our biases as humans, as developers and implementers, that goes into the algorithms. AI doesn't bring up any of its own morality or values or bias into the system. We're talking about data created by humans, about humans, and algorithms developed by humans. So in every step of the data collection, data creation, processing, and use and implementing, we're talking about humans. I put the cognitive bias codex here. You might have seen it before. I'm obviously not going to go through every single one of them, but it's just a visual that reminds me and helps me to relate how many biases that might be involved in our decisions unconsciously, and also kind of taking some of them out here in terms of showing some specifically for algorithms and AI, just some and underline some of the biases that might go into the development and implementation process. If you would like to read more about this, or if you want to go deeper into these topics, we definitely have, I can definitely help out with that in the future as well. But let me move to the next slide, where, like I mentioned, the different points that all these biases can leak into the system unconsciously and into the algorithms. And again, I want to underline some, given the time limits we had on this call. I really wanted to take some high-level ones, but I can go on for hours and hours just listing some of these points. So first of all, when we talk about algorithmic solutions or AI products, the first question ever is an AI solution definitely what we need? Is it the solution to this problem? Just because the very simple way of putting this is, just because we can, should we build and use this AI? Just because we can, should we build an algorithmic solution to provide a risk score for in criminal justice system? Just because we can, should we provide this or create these solutions in different parts of recruitment or welfare eligibility, etc.? Yes, AI comes with, or algorithmic solutions comes with their efficiency and scalability, but the first question is really, is this solution to this problem? Only after we confidently answer that question as a yes, then moving on, AI bias can leak into the systems in terms of framing, in terms of the data that you use, in terms of the structure of your team. So, just to name some of those, pull some of those out, what is the problem we're trying to solve? What are our outcomes and success look like? What are our assumptions in framing this framing this problem as well as the solution? How did I get my data? Again, your output is only as good as your input. How did I get the data? Do I know enough about my data set? Is it representative? Is it labeled accurately? Do I know, or anyone in the team know, the context and historical aspects of this data? Is it good enough at the end of the day? Moving on to teams, we are a group, WATC, and the other groups and other parts that they're very dear to my heart. We are very aware of the diversity issues in our organizations and in different teams. Looking at how bias can leak into the system, how diverse are my external and internal stakeholders? Do I have access to expertise, subject matter experts in the context? Who's making ultimately, who has the purse strings and who's making the decisions? You might have the best team, diverse team, but it might be the CEO, the project manager, the company owner that makes that ultimate decision. Or can I, if I have any ethical concerns during the product development cycle or implementation or any point, can I raise my concerns with retribution? Moving on, we can have bias issues throughout our processes. How do I manage my processes internally and externally? How do I protect data? How do I manage the changes to our model? Can I explain the decisions made by the algorithm, or with what accuracy? Is that good enough? Is a 60, 70, 80, or even 90% accuracy good enough when we're talking about high stakes in terms of like health decisions, criminal justice system, welfare eligibility, recruitment? What kind of accuracy we're talking about that we can accurately explain the decision making, and is that good enough? How do I handle errors, or are they even errors? How do I handle outliers in my model? And again, with the best of intentions and with the best of processes, checks and balances, you might have a great team on the developing side, but there might be bias going into these systems in the implementation side, on the client side as well. How they are interacting with the model or with the product. Are we still using the model for the same problem that we started at the very beginning? How do we train the end users? What kind of answers that they're getting, or how are they using the system? Are they able to challenge the product and the decisions and kind of feed that back into the cycle? What is very important here is AI ethics, or ethics in general, is not a plug and play product. You cannot just fix one piece, or you cannot wait until the product is ready to do an ethical review. It's in every single decision that we make, and all those decisions that we make here across the life cycle has the potential to introduce subjective decisions and biases into the product. You talked about principles, some 70 plus principles. What the industry is going through right now is being able to put those principles into practice and action and actually have tangible results around this. We have some frameworks, guidelines, checklists that are published or that are being piloted or used across different organizations. But still, it is a very fragmented approach right now, and we are still moving towards different solutions and discussing those. And also talking about, I just wanted to put it out here because of what WATC does. This is the gender imbalance in AI across the 23 kind of top countries that have AI research or more focused on AI research. What we are experiencing across finance, fintech, big tech, and technology company is in general is not very different when it comes to AI research as well. The representation of females across any country is very, very low compared to the male developers or researchers. So that definitely has an impact, downstream impact on the diversity of perspectives, diversity of the inputs that are coming into these products, as well as the issues being raised with this. So why is bias so complex with an AI? Like I said, we're making trade-offs with the data set. You might not have, especially if you're a small company, you might not have all the, or have the capacity to build our data against the questions that you want to answer. So a lot of the times you make some trade-offs with the data that you can find, or you kind of try to process the data in a way that it fits your problem and your model, which will create some bias. You might have imperfect processes. So if you go back to the previous, if you remember the previous slide, there are a number of processes involved in the development of a product cycle and implementation that you might have issues. Unconscious bias, we've already gone through. Lack of social context, especially when you're looking at developers. Their work is usually more focused on the technical side of the models or the data, and not necessarily knowing, it's not usually their responsibility or within their training and applications to know the social and historical context of every single data that they're using. AI itself doesn't have any sense of morality or values. And ultimately, the definition of fairness itself, and we're talking about fair AI or ethical AI, you got more than 20 different definitions of fairness that you can mathematically represent, you know, when you're making a choice in terms of which one or multiples of those fairness that you are going to work with, you are again making a subjective decision. And then also, we don't know what we don't know, you know, unknown of unknowns, unknown unknowns. Sometimes, again, with the best of intentions, you might create a product, gone through all the checks and balances, implemented, and then see the implications of that or negative consequences of that. The important thing here is being able to, you know, having built into your cycle those feedback loops and monitoring processes. So when something that you didn't know comes up, you can correct and mitigate that, so it's not an unknown, or it doesn't remain as an unknown issue. So that's almost like the unconscious or unintended piece of it. But as with everything, you might also have people who have the power to take action to end injustices or biases, who will be oblivious to the other side of experience, or might be invested in the status quo because it serves them, or might have been implicitly and explicitly trained to preserve their position. You know, at this point on the spectrum, you're now edging to intentional discrimination, which there are so many things, there are only so many stuff that you can do about that with the lack of regulations. But I am very much a believer in good intentions and humanity. I'm still trying to keep my belief in humanity. So I'm going to focus on the unconscious piece here. So I know I'm going pretty fast and kind of trying to hit at some high level some of the definitions and, you know, issues around bias and algorithms and ethical AI discussions. So now I'm going to move on to the recruitment side of it for the remainder of our time. If you have been enrolled in any recruitment or have been in any conversations, you might have heard about this recruitment funnel. And what that means is, you know, being able to target as many passive and active candidates for a role that you're looking to hire. and then kind of narrow that number of candidates through the different process or stages of the recruitment process until you make a hiring decision. So we're going to go over at a very high level some of the stages and the products that are used and what it means to have, again, where bias, algorithmic bias can be an issue in every stage. So about 3 years ago, 2017, LinkedIn Talent Solutions had this forecast on how will AI and machine learning likely impact recruiting activity. And what they've done is they looked at all the activities that are involved in recruitment and kind of mapped that on a 4-box quadrant or a quadrant, looking at the automation potential from high to low of those activities, and then value added with human touch, supposedly for low to high value added. So what you're seeing on that left bottom quadrant in yellow is what they suggest as activities that have the highest automation potential and the stuff that you can do through automation that would add, that you don't really need too much human touch. Interestingly enough, that's pretty much most of the recruitment process, the main recruitment stages. What we have seen since then, and a few years before this actually, a lot of vendors that are, or platforms that have mushroomed that are focusing on this quadrant. And then recruitment marketing, which is on the gray bottom right quadrant, has kind of moved into that space since then as well. So let's look at the top top step in the funnel, the advertising and targeting piece, and kind of moved our way through these activities. So like I said, any recruitment activities starts with targeting and advertising of the opportunity to passive and active candidates. The main question here is, do you even know the opportunity as a candidate, and how is bias involved in this? Today, employers have access to the same micro-targeting and behavioral targeting tools where they can choose to use these tools in determining the overall demographics of who learns about just job postings and ultimately who applies. If you don't, the first step is being able to know, like being in that audience of people who know the opportunity to even be able to be eligible for that opportunity. Many adworks use the data both provided by your behavior, online behavior and online activity as a candidate as well as a recruiter to create groups of users with shared attributes that can be then used to target the ads. So on the left here on the slide, you're looking at if you're a recruiter using a LinkedIn cert license. These are some of the ad options that you would be using, or you could use if you wanted to target the audience and what they call zero in on your ideal audience. So obviously you have issues there, like you have criteria there like gender and age, which actually are protected attributes. But leaving that aside, and the fact that with any of these criteria, the recruiter himself or herself is making a subjective decision, what happens with the AI side of this is the algorithms, and LinkedIn is not the only one in this obviously, is learning from the recruiter behavior. So after multiple times of using these tools or ad options, it might actually narrow down the options available or kind of classify the groups or generate groups of users with shared attributes and kind of narrow that pool. Also, when we're looking at postings, job postings in the platforms or at platforms like Facebook or Google, they also have their own algorithms that sits on top of this criteria. So as a recruiter, you might choose some of this criteria, say all females at the age of 30 to 35 with a degree in computer science. It doesn't mean that all the females in the platform that are members of that platform are going to receive that. The Facebook and Google run their own algorithms and decide who to show these ads, where they look at the potential or possibility of someone clicking on the ad or taking action, such as applying, and only show it to those candidates. So you have multiple layers of a targeting process where algorithmic decisions are being made. One of good examples of this came out of research that was done, say 5-6 years ago by Carnegie Mellon researchers. They built an automated testing rig called AdFisher and created more than 17,000 fake profiles, male and female profiles, and only visited job seeker sites with these profiles. They were shown more than 600,000 adverts that the team then analyzed. One of the findings that came out of this experiment or research was Google was displaying adverts for career coaching service for executive jobs that pay more than 200,000, so very high level executive jobs, to more males than females. And it's not a small difference. It showed jobs to 1,852 males versus 318 times to the females. So even if you pass the recruiter's unconscious bias in selecting the criteria and the algorithm of the platform, you don't have an extra layer of potential algorithmic bias when it comes to these ad platforms. So let's assume that we pass that and you kind of narrow the applicant pool, and we're now in matching state, where we're looking at the information in candidate's profile or CV resume and kind of match that with the criteria or the filters that the company or the recruiter is interested with. So this will be tools like ZipRecruiter, Glassdoor, Upsider, etc. Again, I'm not picking up any of these companies that I'm giving examples here. I just want to show that even such big names can have issues when it comes to algorithmic bias. So you should be careful, really, as users, as recruiters, companies, when we're looking at products like this and trying to bring those products in our company and in our processes. So let's look at the one on the side on Upsiders. What you see here is the search results for what looks like 325 results for that particular job role, UX designer in New York or Boston. And the recruiter has already filtered applications by certain criteria. So this is a choice architect, right? So the way that the system Upsider builds the platform and kind of has the UI design on the platform can introduce some biases. So when you're looking at a percentage match, just like you have on dating sites, a 98% match that it shows numerical scores and rankings presented like precise and objective results might actually have the recruiters give them more weight than they truly want, or even the vendor intended. So we don't know how that 98% match was calculated with, let alone its validity. The other thing is, again, here you can create default projects, or the system can create defaults, learning from the recruiters as well as the candidate on the platform's choices. So whenever you have personalized features, the algorithm at the background is customizing the selections and kind of making suggestions accordingly. But going back to, again, content-based and collaborative filtering risks in this and the choice architecture, it even matters when we are talking about how many candidates that a platform is showing in one page versus if I'm showing only the top 10 per page versus the top 20, and then looking at this percentages of matches, the recruiters might not be willing or interested in moving forward than 2 pages down the candidates, taking these percentages as objective results or facts, and kind of narrow down. So the algorithm has already narrowed down with its structure, its architecture, as well as the machine learning that learns from your behavior. So moving on to, and then because of time limitations on this call, I'm literally going really fast and limiting it to a few examples in each stage. But let's move on to screening and what some of the bias and shortcomings of these algorithms might be, as well as the inaccuracy and unrepresentativeness of the data sets might result. So again, Amazon is one of the biggest examples on this. Around 2014, they had this project on kind of looking back over their 10-year period of resumes submitted, and they built an algorithm, machine learning algorithm, that was trained to vet applicants by observing patterns, and then use that in their own screening process. What ended up happening is the algorithm penalized resumes that included words that were related to women's club, women's colleges, etc. In short, the algorithm or the system taught itself that male candidates were preferable. And this was really because, one, most resumes came from men, which is in itself is a reflection of male dominance across the tech industry. So you had an unrepresentative or undiverse data set, if you want to call it. But also the parsing and analysis of the words is related to the natural language processing capability of these models. And also, even if you're not only, it shows that even if you're not looking at the protected attributes like gender, age, race, etc., that there might be proxies for protected class information that might still end up with biased results in your algorithms. If you have seen Black Panther, you might be a big Okoye fan like I am. So I really like this example here. So a number of pictures from Black Panther characters was fed into this analysis on this research. And they took 5 top facial recognition software and emotional facial recognition software that are used, and looked at the accuracy of the results. So out of the 5, and just as an example, Okoye is a 39-year-old female Wakandan. So out of the 5 softwares, and these are like the top 5 softwares that we're talking about, 2 of them didn't even recognize that it was a person that it should analyze. So, and then out of the remaining 3 that detected the person, only 1 was able to kind of look at the age and get a range correct, and I'm saying range. Only 2 of them were able to detect the gender correctly, and none of them was able to detect the race correctly, although we know that race is a social construct. Unfortunately, it is still being used by, you might call this systems. But what that means is any facial recognition software that you're using, whether it's recruitment or safety, public safety, predictive policing, etc., your accuracy levels and your trust levels are going to be really low as long as these data sets that are being used and the recognition software's results are coming up with this results. Another study, another research by Joy Blomini. If you haven't heard about her, I strongly suggest that you do. She's got a great research with Timnit Gebru on gender shades and accuracy of facial recognition softwares, as well as the implications of getting that not accurate. So they run different pictures of males and females with different shades of skin color or skin type across some of the top facial recognition softwares again. When we're looking at accuracy by gender, you'll see almost up to 21% error gap between males and females, and up to a 19% error gap between darker and lighter skins. Again, if you're using this in recruitment or any facial recognition software or product, it means that if you're a female, that you're in trouble. If you're a female with darker skin, that you're in really trouble in terms of the accuracy and being able to successfully be detected or processed correctly. And it's not only the skin color or the genders, but when we're looking at accuracy in terms of ancestry, we also have issues that expand beyond this. But also when I didn't put any examples here, but we might also have issues in terms of facial recognition softwares or softwares using facial recognition when we're talking about people with disabilities, where the facial, some of the facial features or their postures, etc., might classify them as outliers or not fit for the screening purposes. And then finally, on the screening side, there are some really unscientific methods where we're talking about facial personality analytics tool that suggests that looking at a picture of a person, the vendor can analyze whether you have high IQ, that you might have tendency to be a researcher, or you might be a terrorist. I'm not going to go into a deep dive argument of what sounds like phrenology or unbiased approach, or give more attention to this than it deserves. However, when you're looking at the verticals that this product is trying to build partnerships, it states public safety and smart cities and matching and recruiting, etc. So this kind of products or approach might be used in say for policing purposes or public safety in different verticals across this. So really need to be cautious of the use cases and the products. And then finally, on the assessment side, we have vendors that do assessments and kind of use physical features and facial expressions that have no credible causal link with workplace success or making an informed hiring decisions, like word choice, word complexity, that might bias against people whose native language is not English, or people with speech disabilities, or people from different ancestries or different backgrounds. And then you also have softwares like this one in South Korea, where the vendor thinks that they can make a decision or prediction on actual performance or competence at work by looking at the vision, voice, verbal, or vital analysis of a candidate during a video interview. And then, mindful of time, when you're at that hiring decision stage, although this is illegal, doing like social background check is illegal in certain states and countries, there are softwares out there that might go into the recruitment process where the software kind of goes through your online profiles, your posts, etc., and kind of give the recruiter or the company a score about you in terms of whether you're a good, bad, in this case, a very bad candidate. What they presume is a person's online behavior and language is relevant to their professional activities, while NLP in itself has limited ability to understand nuanced meaning of communication or detect the intent or motivation of the speaker. And it might also, again, can surface details about an applicant's race, sexual identity, disability, health status, potential pregnancy, etc., which should have nothing to do with the hiring process. Who's responsible when things go wrong? Unfortunately, there's not many legislation currently or regulation that creates accountability and liability around this, and whatever we have is pretty outdated and needs to be reviewed in terms of the new technology that is being used. I just want to put it out there that when we move fast and break things, we might be breaking things that we didn't intend. So going back to that full cycle, product cycle, and building ethics and responsible AI in our products, we really need to look at the upstream and downstream implications and our intent. I'll do a shameless plug here. If you want to go into more detail on any of these topics, I do have a 6-week course starting in about 10 days. So looking forward to seeing you also there, but I hope I was able to at least create some question marks around this products and our responsibility around ethical AI.